Hello everyone, I'm Siddharth and today I'm gonna be walking through LTspice. So LTspice is a SPICE tool. SPICE stands for Simulation Program with Integrated Circuit Emphasis. Basically, you can run all your electric and electronic circuits in a software platform. So before we begin, I'll let you know how to install LTspice. So go to Google, type LTspice, the first link from Analog Circuit website, click on it, and there it will take you to the page. There you need to respectively select your platform either for Windows or for your Mac. I've installed on Linux via Wine. Not an issue to worry right now. So now let's get started. So once you install LTspice, you open it and you're greeted with this screen. So in order to start building circuits, you right click, new schematic. Now you have your schematic window. So to show a demo, I'm just going to build a basic NMOS IV characteristics. So in order to do that, right click, draft, component. Type NMOS 4 since we don't want the body terminal to be free as well. And you paste it here. Now we have done the NMOS. Let's add a few voltage components. So draft component voltage. Yeah. So we need a VGS and a VDS. So hold Control and R in order to rotate it. I'm sorry, one sec. So hold Control and R in order to rotate. Yeah. So now the components are done. We just need to connect them via wires. So in order to do that, I'm gonna select a ground pin. So right click, draft, a label net, ground. Okay. You add a ground pin here, you add a ground pin here, and you add one here. Now right click, draft, draw wire. So you connect the components basically. Oh yeah, I forgot to tell. So once you're done putting components or adding wires, you can always hit the escape key to get back to your regular cursor. As you can see right here. You can click and drag in order to adjust the way it looks. Oh yeah, I forgot to short the body with the source terminal. So right click, draft, draw wire. Alright, so the schematic is done. So now I want this to be similar to the GPDK 180 nanometer technology, basically the one we use in the cadence tool, in particular the cadence virtuoso. So what I have done is I found a file called PTM180, which is more or less similar to the GPDK 180, which works for SPICE simulations. So the thing you need to do is you need to save it in the place where you save all your SPICE folders. Basically, it's your C drive, users, the username, and my documents. Let me show you once. Since I'm using Linux, I need to go through Wine, since Wine is the application I use for using Windows. This is your C drive, users, username, my documents. Yeah, this is the file I'm talking about. It's PTM GPDK 180. So I'm going to be using this in order to simulate my circuit. Let's start. So now, since my schematic is ready, I'm going to give a certain value for the voltage. Let's give it as V. Okay, first let's do the transfer characteristics. So for that, I'm going to give the VDD as 1.8. And let's change the length of the NMOS to 180N and the width to 2 micro. All right. Okay, now in order to get started with simulation, you need to basically right click, draft, spice directive. In the spice directive, you can again right click, help me edit, analysis command. Oh wait, I forgot. Before that, if you want to use a GPDK model, you need to type dot include and the name of the file. We are using this file so that all the plots we get are more closer to the GPDK 180 simulation as we do it in Cadence. So since the name of the file is ptm gpdk 180, I'm going to write dot include ptm underscore gpdk 180. It's a text file, so dot txt. Click OK. So as you can see here, I'm going to go to your C drive, users, username, my documents, LTspice. It will be created by default when you install LTspice. There you need to save your GPDK 180 folder. To use it, you always write dot include ptm gpdk. And now since I'm plotting the DC analysis, this is the command which has been written, which is automatically written based on how you create it. Yeah, it'll be pasted right here. Okay, now let's get started with plotting. Right click, draft, spice directive, right click, help me edit, analysis command. So in order to plot the transfer characteristics, we're going to go for the DC sweep. So the first source we want to sweep is V1, that is your VGS. So V1, the type of sweep, let it be a linear sweep. We're going to start from 0, let it go up to 1.8, and maybe increment it by 0.01 so that the graph is more smooth. Yeah. So, okay. Yeah, you drag it here. All right. So I guess we can get started right now. So in order to perform simulations, there is this person who's running. This is the icon you need to click in order to run your simulation. Now let's run the simulation. All right. So simulation window is open. Now if you want the IV characteristics. So since you obviously want the current, the cursor will automatically switch depending on what it is. If it's a red pin, it plots the voltage. If it's a black color like pin, it's current. So now I'm going to click on it. As you can see, the transfer characteristics is in. You can zoom in again. So this is the transfer characteristics. Yeah, that's good. So now let's plot the drain characteristic curve. In order to plot the drain characteristic curve, what you basically got to do is vary this, keep this as V, and fix this at around, let's say, it should be greater than threshold. So I'll keep it at like what, 0.9. I think I'll keep it as 1 volt. Yeah, that's good. So now here you want to edit the command and vary VDS. So the name of the source to sweep is VDS, so V2. And let's run the simulation again by clicking on this option. So now you run the simulation. As usual, it's again the IV characteristics with VGS being independent, basically being constant. So you click on the current flowing across the VDS, that's the ID, and here is your VDS curve. As you can see, it's not perfect because the GPDK 180 model also has a bit of channel length modulation, as you've already learned in theory class. Yeah. So now, if you want to plot the parametric analysis, now let's just say that these two values are fixed. I'll keep this as 1.8. I'll keep this as 1. But let's vary the W. Oh, I'm sorry. Let's keep this as V itself. But let's also vary the W. So width, we're gonna keep it as flower brackets W. This is how we plot the parametric analysis. So now this will obviously give us the drain characteristics, but if you want for multiple values of W, you need to right click again, draft, spice directive, and you need to type in the following command. Yeah, just a moment. So you right click, help me edit, step command. the name of the parameter you want to sweep, it's obviously W. You want to start from around, let's say 2U. Let's go up to 50U. Let's increment it each time by 4U, I think. That's better. Alright, let's plot the output. Run. As usual, what you need to do right now is click on the ID terminal since you are plotting the drain characteristics, but this time you'll get multiple graphs for the various values of W. It's gonna start from 2U and go up to 50U with steps of 4U. So as you can see, since I put 4U, it basically plot 2U, 6U, 10U, etc. So on till 50U. These are all the various curves. Yeah, thank you for watching.